Hello friends, welcome to Risingpearl.com. Today we're starting a brand new series 7 called Quadratic Equations. This is webisode number 1. So friends, why don't we begin by talking about what is a quadratic equation. So now let's take a look at one of the questions. John's mother is 20 years older than him. The product of their ages in 5 years from now will be 800. How old are they? The reason I'm asking this question, friends, is that our goal is not to really solve this question. But let's think through what is going to be our approach. So let's say John's age. So John's age today, we are going to think something like this, right? His age today is X years. He is today X years old. So John's mother will be, how old will John's mother be? John's mother is 20 years older than him. So if John is X, his mother's age is X plus 20. This many years. Right? Now, 5 years from today, 5 years from now, how old will be John? John will be X plus 5. This will be age of John 5 years from now. How old will John's mother be? John's mother will be X plus 20. This is her current age. X plus 20. Then plus 5, because 5 years later she'll be 5 years older. Or this will be equal to X plus 20 plus 5 is 25. So now what is given is that the product of their ages 5 years from now will be 800. That means you will have X plus 5, which is John's age, multiply by X plus 25, which is his mother's age. This product is 800. Now we need to be able to solve this to find out the value of X. So that is how we will know what is John's age and what is John's mother's age. Right? So in order for us to solve this, you should see that here if you multiply this, if you were to open the bracket with the parenthesis, what will happen? So X, you have to multiply X by each of these terms. So you will have, let's very quickly write this, you will have X squared plus 25X, which is basically the first term here. X is multiplied by X and then multiplied by 25. Then plus 5 you have to multiply with X and then multiply with 25. So then when you multiply plus 5, you will have plus 5X plus 5 times 25 is 125. Now this is equal to 800. So you see that what you have here is you have an equation, because there is an equality sign. So there is an equation. This is an equation. And the highest power is, this is raised to power 2. That means this is actually a quadratic polynomial. We have seen from our last, or I think like it was series 5, we learned about what are polynomials, and we have seen extensively what is a quadratic polynomial. So when a polynomial is raised to power 2, so that is a quadratic polynomial. So we have a quadratic polynomial is equal something. So how do we solve them? Well, we have not yet learned how exactly to go about solving them, but I want to highlight to you that this is not something that we can actually use linear equations to solve and find out the values of, right? Now let's take a look at one more question. The product of two consecutive numbers, so there are two consecutive numbers, their product is 210. What are the two numbers? So if you think the first number is X, the second number must be X plus 1, right? Because they are consecutive numbers. So 3 and 4, they are consecutive numbers, right? So similarly 52 and 53, they are consecutive numbers, right? Basically the difference is 1. So X, and so the first number is X, so the second number must be X plus 1. Well, I mean, some of you can say that how about the second number is X minus 1, and that will be equally correct as well. And it is given that the product of the two, so if you multiply these together, you will be getting 210. That is what is given in the question. So again, in order for us to solve this, what we are going to do is we are going to open the bracket. So X times X is X squared plus X times 1 is plus X equal to 210. So again we see this familiar thing where we have to solve something which is basically, clearly it looks like it's an equation, there is an equality sign, and we have a polynomial on this side, and it's a quadratic polynomial. we have not yet seen how do we extensively go about solving quadratic polynomials. But we have seen in our series 5 how do we factor quadratic polynomials when we were looking to find out the zeros of them. But here what we are seeing is that we have a polynomial, quadratic polynomial equals 210. So similarly, friends, I can give you lots of such questions, examples, and I think subsequently in the series we will be going ahead and solving these questions. But for now, again, if you take a look at this question, sum of areas of two squares is 468 meters squared. If the difference of their perimeters is 24, what are the sides of the two squares? Again, friends, if you actually try to solve them logically step by step, so you will assume that maybe the first square, let the side of the first square be x, and let the side of the second square be y, right? So the area for this will be x squared and the area for this will be y squared. The sum of the two areas, if you were to add them, you have 468. But the difference of their perimeters, so a square, the perimeter will be this for the first square, perimeter of the second square will be this, and the difference, if you assume the first one is bigger than the second, the difference will be 24. That is what is given. So again, from here you can find out that, so what we can say is, we can say, well, 4 can be taken as common, so you will get x minus y equal to 4 is common, so this will be 6, right? So 4 will cancel out, dividing both sides by 4. 4 6 are 26. So from here we can say that you can simply take the y on the other side. So from here you can say, well, x is equal to y plus 6, right? So by taking the y on the other side, we are just trying to write one unknown in terms of the other unknown. Why are we doing that? So that in this first equation we can put this value. So instead of x here, we are going to put this. So what you will see is you will have y plus 6 whole square plus y square equal to some number which is 468. So again, friends, our focus has not been to really go ahead and solve them, but again you see that you have a polynomial whose highest degree is 2. This is again a quadratic polynomial here. If you open this up, you will get a y square term and a y term. So the y square will be the highest power. So this is again a quadratic polynomial equals some number. So friends, now let's understand, let's have a quick recall of what is really an equation. If you recall, equation is nothing but we start with a polynomial, we have another polynomial, and we simply put an equality sign in between, because the moment you put equality sign in between, it becomes an equation, right? So one polynomial equals another polynomial, that becomes an equation. So the quadratic equation, which is the topic of this series 7, what is a quadratic equation? So it is exactly the same as any other equation, with the exception that the highest degree to which px or gx should be raised, must be raised, is 2. That means that either this one should be a quadratic polynomial or this one should be a quadratic polynomial. So you have one of them should be a quadratic polynomial, and that should be the highest degree, meaning you cannot have a quadratic polynomial and a cubic polynomial, right? Or a quadratic polynomial and a polynomial of degree 4 or 5 or anything else. You can have a quadratic polynomial and a linear polynomial, that works. So friends, this is basically what is a quadratic equation. So now let's take some examples. So if I were to write something like, let's say 2x squared plus x plus 5, this I'm randomly writing some equation equals x minus 2. This is perfectly a valid example of a quadratic equation, because we have a polynomial, this is a quadratic polynomial, equals a linear polynomial. So this absolutely works. Also, you could have written the same thing as 2x squared. Let's get this x on this side. So the x and x will cancel out, right? And then when you get the 2 on this side, it will become plus 2. So this will be plus 5 equal to 0. So this is again a perfect example of a quadratic equation. I'm just trying to make sure that you realize you don't have to have a px like a polynomial on this side and also a polynomial on this side, because we started out with polynomial on both sides, but we can always rearrange the terms. We can simply move all the terms on the right side onto our left side, and then we'll end up having one new polynomial which will still be of the degree 2, and that will become 0, right? So essentially, so these are all examples of a quadratic polynomial. So what is not a quadratic polynomial? How about if you have x plus 6 equals 2x? Is this a quadratic polynomial? Answer is no, it is not. Why? Because this is a linear polynomial. We do not have any of the polynomials a quadratic polynomial. So the highest power is 1 to which x is raised. Similarly, if I have something like 5x cubed plus 2x equals 10x, let's say 10x to the power 4. Is this a quadratic equation? No, because the highest power to which the variables is raised here in this case is 4. So this is also not allowed. So remember that the highest power to which any variable is raised must be 2, right? And there has to be one of them, because I cannot have, linear equation where there are no quadratic polynomials, and I cannot have a situation where the powers are greater than 2. So I need to have the highest power of the to which a variable is raised in that equation must be 2, and that will be a quadratic equation. So if you just take a look, go back and you take a look at these questions we have talked about. So this is an example of a quadratic equation. Similarly, if you take a look at this one, this is again an example of a quadratic equation. And so is the very last one that we looked at. This, if you open this up, basically you have a quadratic equation. So friends, this is what is meant by quadratic equation. And throughout this series, we are going to learn different aspects of quadratic equations, and obviously how do we solve these equations.